Hello everyone, I'm Paul and today we're solving problem 1262, greatest sum divisible by 3. This is a medium one that might seem tricky, so here we will go step by step. Given an integer array nums, we need to return the maximum possible sum of elements such that it's divisible by 3. So if we are given this array, here the total sum is 21 plus 4, 25 plus 3, 28. And if we do 28 modulo 3, this is 1. This means that 28 is not divisible by 3, so we need to remove one or more elements from the array. And here we are trying to get the maximum possible sum after removing the elements. The solution is to remove this and this, and now the total sum is 21 plus 3, meaning 24. And if we do 24 modulo 3, this is 0. This means that 24 is divisible by 3, and this is the maximum number that we can get, so we return 24. So let's go from the start. Let's say that we have this array, we don't have these elements, and here the total sum is 21. If we do 21 modulo 3, the result is 0. This means that 21 is divisible by 3. So if we take the total sum modulo 3 and the result is 0, we can return the total sum right away. So in this case, we would return 21. Now, if we take any sum modulo 3, the result can be 0, 1, or 2. And this is very similar to if we take any number modulo 4, for example. The possible results in this case are 0, 1, 2, and 3. The possible results are given by these 3. Now we know that if the sum modulo 3 is 0, we can return sum right away. Now the question is, what if the sum modulo 3 is either 1 or 2? What do we do here? So for this example, we have a total sum of 28. And this module 3 is 1. So we are standing here and we want to move to 0. We need to remove one or more elements to reach here. So let's see how the divisibility of each of these elements affect this final result. For example, let's say that we are here. If we do 3 module 3, okay, because we need to find a sum that's divisible by 3, the result here is 0. This means that we can keep or remove this 3 and it won't affect this number. Now, what if we take 7? If we do 7 module 3, this is 1. This means that this number has an effect in this number. If we remove this from 28, it's as if we were removing this from this. If we do 28 minus 7, this is 21. Module 3, the result is 0. Okay? So if we take the total sum module 3 and it's 1, meaning we are standing at this scenario, we can remove only one element, for which when we take that element module 3, the result is 1. And that's how we can reach a 0 here. So the final result, if we remove this, is 21. And we will call this scenario remainder of 1. Here we are removing only one element, which has a remainder of 1 after doing the element divided by 3. And just to be clear, this is as if we were moving from here to 0. Now we have another strategy, which is to go from this point to minus 3. If we go to minus 3, it's the same as if we go to 0. Why? Well, because this is divisible by 3. We can pick two numbers with a remainder of 2. We know that every one of these numbers divided by 3 has a remainder of 1. We know that this has a remainder of 0. And if we do 2 module 3, this has a remainder of 2. So we can pick two of these numbers And by doing this, we are subtracting 2 times 2 from this. And 1 minus 2 times 2, meaning 1 minus 4, is minus 3. And if we are standing here, it's the same as being here, okay? So if we remove these two elements, now the total sum is 21 plus 3, meaning 24, module 3, this is 0. So for this scenario, the result is 24. And remember that for this scenario, the result was 21. We need to return the maximum possible sum, so in this case, we return 24. Now, what if the total sum module 3 was 2? Well, here we would be standing here. Now the question is, how can we go from 2 to 0? Well, we can subtract two numbers with a remainder of 1, and by doing this, now we are here. Or we can subtract one number with a remainder of 2. And 2 minus 2 is also 0. Okay? So, if the total sum module 3 is 2, we follow this strategy. And if the total sum module 3 is 1, we follow this strategy instead. Let's see one more example here. The total sum in this case is 23. And 23 module 3 is 2. So we are at this scenario. We can either remove two elements with a remainder of 1 or one element with a remainder of 2. So let's get all the reminders here. 3 modulo 3 is 0. 6 modulo 3 is 0. 5 modulo 3 is 2. 1 modulo 3 is 1. And 8 modulo 3 is 2. In the code, we are storing numbers with a remainder of 1 in this array and numbers with a remainder of 2 in this array. We are not storing numbers with a remainder of 0 because remember that these have no effect in this number. So let's go with this scenario first. We need two numbers with a remainder of 1, and given that we only have 1, we can't go here. We need to continue with this scenario. Here we need one number with a remainder of 2. But here we have 2. Now the question is, which one should we remove if we are trying to get the maximum possible sum? And the answer is the smallest one. That's why we are sorting these two arrays and we are always keeping the minimum elements, okay? So we know that we need to remove 5 in this scenario. And given that this is the only possible scenario, we remove 5 and this is 18. And 18 module 3 is 0. So we return 18. And just to be clear, this is as if we were going from 2 to 0 using this strategy. We are removing an element with a remainder of 2. Okay, only one element with a remainder of 2. That's how we go from here to here. And here, overall time complexity will be big O of n log n, which is given mostly by sorting and building these arrays. Remember that we are iterating these to get every remainder, and we are also sorting this. And space complexity is big O of n. Remember that we need this for sorting in Python, and we also need to build these arrays. So with this in mind, let's go with the code. First, we need to build R1 and R2. Remember that here we are storing the reminders of 1 and reminders of 2 after dividing every element by 3. So this is an array with x for x in nums if x module 3 is 1. And remember that we need to sort this because we always want the smallest elements. And we are doing something very similar for R2. This is exactly the same, but here we put a 2. And this is R2. Now, the sum is initially the sum of nums, and we need to remove some elements potentially. This is initially infinity. We write infinity like this in Python. And now we can say if the current total sum module 3 is different from 0, we have two possible cases. If the sum module 3 is 1, we will do something, and if the sum module 3 is 2, we will do something else. Now, if it's 1, we say if R1, if we have something in this array, remove is now the minimum between remove and R1, 0. We are removing only one element. Now, we need to do our second strategy in this case. If the length of R2, the length of R2 is greater or equal to 2, here remove is the minimum between remove and R2, 0. We are removing two elements here, plus R2, 1. And we are doing something very similar for this scenario. If the length of R1 is greater or equal to 2, remove is the minimum between remove and R1, 0 plus R1, 1. And if we have something in R2, remove is the minimum between remove and R2, 0. Okay. Finally, we can return the final sum if we didn't have anything to remove, meaning remove is still infinity. Else, we return the current sum minus remove. Okay. So this is the entire code. I think this is right. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.